So, variation. So, there's some word problems today, but not like the previous section. These are pretty easy. We're going to start looking today, when we talk about variation, how do quantities compare with one another? Meaning, are they both increasing? Does one increase while one decreases? We're looking at how the different quantities relate. And there's really three different types of possibilities or variation we're going to get into. Direct variation, inverse variation, and then we're going to kind of do a combo where you could put some different styles together of variation. So we're going to start with the easiest one, direct variation. So direct variation occurs when one quantity is a constant multiple of the other. Now, what does that really mean? So I'm looking at that y equals kx equation, which is going to be our best friend. We have something, of course, similar. I just swapped the k out for m if we have slope. So let's say I gave you y equals 5x. That's an example of direct variation, meaning whatever you select for x directly determines what your y is. If I put 2 in here, y is 10. 5 for x, y is 25. They're directly related. They're both increasing. As x increases, y increases. As I eat more cupcakes, I gain more weight. Okay, they're both going up together. They're increasing together. So we say y varies directly as x, or some textbooks use this phrase, y is directly proportional. You'll probably hear me say varies directly a little bit more, just because that's kind of what I'm used to, but means the same thing. And just remember, of course, I know you know, but for drama, product between them. K times x times. Because what do you think inverse variation is going to switch to? What's the opposite of times? Divide. It's going to switch into division. So that's going to be really the difference when we get to it. But let's do some direct variation first. Wordy, but I promise easy, okay? During a thunderstorm, you see the lightning before you hear the thunder, because light travels much faster than sound. The distance between you and the storm varies directly. And the problems will always tell you what type of variation it is. You don't have to magically read it and figure it out. They're going to tell you, you just got to read closely. Is the time interval between the lightning and the thunder. Suppose that the thunder from a storm 5,400 feet away takes 5 seconds to reach you. Determine the constant, that's the K, of proportionality and write the equation. Okay, so I'm back to the top up there, the top little sentences to get my equation set up, because it tells you the distance. So instead of y and x, I'm going to use letters that represent our quantities. So they're telling you the distance between you and the storm. So I'm going to use d for distance. K for your constant. I'm going to put the dot in for my dramatic multiplication. Varies directly with the time. So I always swap out the y and the x for letters that make sense to my specific word problem. I just think it's a little easier. All right, now let's actually get into this. So suppose that the thunder from a storm 5,400 feet away. So of course 5,400 feet, that's your distance. So I'm going to replace d with 5,400. And it says it takes 5 seconds. So there's your time. So I said you might want your calculators out today, because you do have to do a little bit of computation. I'm going to get k solve for. I'm just going to divide off the 5. Okay, so I punched that in my calculator earlier. 5,400 divided by 5 is 1,080. So my final answer, okay, determine the constant of proportionality. Got it. Write the equation for the variation. So all I want you to do for your final answer now is now that you know your constant, what's relating your quantities, is just pop that back in there and put your final equation is the distance equals 1,080 times the time. All right. So that's as wild as it's going to be today, my friends. Sketch the graph of this equation. I got to be honest, sketching the graph of it to me isn't really all that exciting. Okay, I'm going to do you a rough sketch, of course. What does the constant of proportionality represent? Of course, you could punch this in your calculator if you want to see the graph. Of course, instead of d, you're going to use your y equals. Instead of t, you're going to swap it out to x. But I don't really need to pull up the calculator and punch that in. You are in slope-intercept form, technically. This would be your slope. What's your y-intercept? 0. Now, okay. if we look at the graph, picture this, you're starting at 0, your slope's 1,080. You're going up 1,080 over 1. Up 1,080 over 1. Is that going to be hard to see on your graphing calculator? Yeah, okay, that's why I don't get excited about these. I care more about that last part. What does the constant of proportionality stand for? So, I mean, sketch the graph. Seriously, okay, we'll sketch the graph. I'm not, again, going to get crazy. Y-intercept 0. You can see I didn't even mark any tick marks. I'm clearly not going to get crazy on it. I should put a note not drawn to scale. I'm going to put like 1,080. I'm just going to slap it on here. Okay. Yeah, okay. Yeah. And that's all I need to for a sketch. Don't make this, the sketch to me isn't that exciting. I care more about this part of it. What does the constant of proportionality represent? Well, of course, it's the slope in our situation, but more important, we want to apply it to our word problem. So that 1,080, of course, is representing your speed of sound, how long it takes to hear that thunder, right? So I'm just going to put represents the speed of sound. Because it's tying together, speed of sound, it's tying together your distance with your time. How long does it take to hear the thunder, see the lightning? So it's tying together the distance and the time, so your speed of sound, basically. I care more about that than the graph. Okay, so C, I could put it all in the same slide here. If the time interval between the lightning and the thunder is now 8 seconds, how far away is the storm? So all I'm going to do is go back here to my green equation, and I'm just going to swap out the time. They give you 8 seconds, and I'm going to have to punch that in my calculator. I'm going to have to figure out 1,080 times 8 for the final answer on that guy. Maybe I already did it. So of course, I typed that in earlier. You get 8,640 feet. Okay, so any questions on direct variation? And again, I think it's easy. I always use variable letters that kind of make sense to your problem. I don't get caught up in the X and the Y. Here they're talking distance and time. D and T. Make it easy. Now, we kind of already gave away inverse variation. If direct variation is multiplication, just going to kind of highlight the division symbol there. Inverse variation, of course, is going to be now division. So, of course, we say inversely proportional, varies inversely. You'll probably hear me say that more. Varies inversely versus the proportional part, but it all means the same thing. Okay, so let's do an inverse one. And again, clearly the next problem, not shocking, is going to be inverse, but they always will tell you in the problem, just read closely, because eventually it'll be scrambled up here. So Boyle's law, I feel like a science class. Boyle's law states that when a sample of gas is compressed at a constant temperature, the pressure of the gas, so right away I'm like, okay, I'm going to use P, varies inversely proportional to the volume. So before I even start reading, hang on a second, Elliot. Before I even start reading A, I'm already thinking, okay, the pressure varies in, oh Lord. That kind of scared me, but anyway, okay. With the volume, Elliot.
I'm curious because the equation is y is equal to k over x. What would happen at the point where x is equal to 0?
Well, you can't divide by 0, so you won't have that situation.
That's what I assumed, but
okay.
Wouldn't x have to, because x could be a negative value.
Well, you're going to have some sort of quantity. It could be. It just won't be 0.
Oh,
and since we're,
like it's only applicable to real world problems?
Correct. You could, like back in the old Algebra 1 days, we just gave you like x is 5, y is 7. We'd give you the numbers. You're going to have more application problems, so yours will be positive. All right, I'm actually going to read A now. Okay. Suppose the pressure of the sample of air that occupies 0.106 meters cubed at 25 degrees Celsius is 50 kPa. Find the constant of proportionality, find K, write the equation. So kind of similar. I don't know if we'll sketch the graph. We'll talk about it. We probably should talk about it, I suppose. So we have to, of course, decipher all these numbers in here and what's going where. So I see meters cubed. As soon as I see the meters cubed, back to geometry. that is representing volume. Remember, volume is always a meters cubed quantity. So I'm going to put the 0.106 in the denominator. 0.06, got it. Okay, at 25 degrees Celsius, now we don't have anything in our equation about temperature, and this is just one of those kind of extra pieces of information they give you, because if you read it at the top, it talks about constant temperature. They're just telling you, yo, the temperature is 25 degrees Celsius. That's not going to affect our equation. Now, this, of course, the 50 kPa, the 50 is your pressure. I'm gonna put that in there. All right, so this is why I said you probably want your calculators today. Just do a little, solving for K on this one. I'm going to get rid of divided by 0.106. I'm going to multiply by that. And I should have left myself a little more room over here. I'm going to sneak it in. I'll get rid of those. And of course, just type in your calculator 0.106 times 50, and you should get something close to about 5.3. If it doesn't say what to round to, as always, I don't get super picky about the rounding. You can surprise me. So final answer, and we'll talk about the graph. Of course, it wants you to write the equation, so all I'm going to do is put my constant back in. So this is telling you your pressure, how it relates to your volume. Now, again, can you take a look at the graph on this one? You sure could, you sure could. I don't think the graph's that helpful. If you were going to take a look at the graph, of course, just swap out the P and the V for X and Y, and you can punch that in your calculator and take a look at it. And it's going to be weird. It's going to be one of those rational expression graphs, kind of you saw some of those yesterday, where you have like the fun-filled curves on there. Again, I don't think the graph is really all that useful to me, so I'm not going to really get into, oh man, my ugly drawing. I'm not going to get into too much of a twist about the graph on this one. You don't either. Okay, if the sample expands to a volume of 0.3 meters cubed, find the new pressure. So clearly I'm putting in 0.3 for the volume, so I'm just into this equation, I'm going to replace the V with 0.3, and then of course we're going to have to divide those out. So I'm going to have V equals 5.3 over 0.3. And of course, I just typed that in my calculator. I rounded that 5.3 to the 10th, so I'm going to do the same to the 10th here. And you should get 17.7. And your pressure, remember, is the kPa. So any questions on the inverse? And same thing today on the homework. If it says to sketch the graph, I mean, you've seen my little hoopty sketches I've drawn on the graphs. Same thing. I don't expect anything great. A lot of times, because these numbers are so big, they're off the screen too, and they're hard to see. Now, last thing we're going to do, boy, so many words on here for a math class, is we're going to talk about if you want to combine some of the different types of variation. So, of course, science relationships between 3 or more variables are common. We've just had the 2, like distance and time, or pressure and volume. You could have 3 quantities or more, or different types of quantities. So one type of variation, and I like the varies jointly, of course. You might have this equation where you've got the 3 different quantities. Again, it's going to tell you. Sometimes they give you something weird like this. Proportional to x, or varies directly with x and inversely with y. So you just have to read closely. And remember, you really have 2 possibilities. Direct variation is product, inverse is quotient. So we just have to kind of read what they give us and set it up. That's as wild as this is going to be. So let's do one. Seems crazy, but it really is a whole lot easier than what it says. Okay. So the apparent brightness, B, of a light source is directly proportional to the luminosity. So I'm going to start with that. I'm going to start with that for my equation. So the apparent brightness, B, is directly proportional, so product, to the luminosity. So I'm going to start with that. I'm just going to keep on reading because then it's getting wild on me. And inversely proportional to the square of the distance. So inverse, of course, now we're going to go into quotient, square of the distance. And I just kind of combo them all like that. If you ever look, like sometimes the answer key, they kind of pre-print them out and they get fancy and put it like this. And to me, I just find that more obnoxious, quite frankly. I see why they're doing it. They're kind of trying to separate out your constant. But again, that's really over 1. K times L is on the top. V squared's on the bottom. I tend to just read it and set it up and make my life easy on it. So there's my equation. I'm going to roll with that guy. And then, of course, the parts B and C, they're going to give us some numbers to plug in here. So let's take a look. So if the distance, is doubled. Okay, all right. So I'm going to come back to this. If my distance is doubled, now remember, that really has a coefficient of 1 in front, 1d. So if I double it, I'm going to put in 2d. Okay, let me switch that to 2d. And don't forget the squared down there, which I'm going to simplify that in a minute. By what factor the brightness will change? Okay, so that's the only thing they're changing. So I'm just going to fill in the rest of my equation. The B equals the K and the L on the top. Okay, B equals. And of course, I'm going to simplify out that 2d squared on the bottom. 2 squared 4. Do you have to keep putting the dot in? No, I just like to for dramatic emphasis on the top. So we have 4d squared. So it says if the distance is doubled, by what factor will the brightness change? So we doubled the distance, and we now have it down here as a 4 in the denominator. Well, dividing by 4 is the same as multiplying by what? 1/4. So you're changing the brightness, of course, here by 1/4. It turns out to be 1/4 as much. So I'm going to say the brightness changes by 1/4 because it's in the bottom of the fraction. Okay. Let's do C. Just more of the same, but they're going to kind of change up the numbers. If the distance is cut in half, now back to my original equation. So my 1d, I'm now cutting it in half, so I'm going to make it half d. We're going to have to square it. Half d. I want that squared. Okay, did it? Luminosity is tripled. So instead of 1L in our equation, let's go back to the original. Instead of just a 1L, I'm going to put that as a 3L, triple, 3L. Let's not forget my K and my B. By what factor will the brightness change? So this is kind of the same thing as the red one. This is just kind of a hot mess, and I need to kind of clean it up here just a little bit, okay? So you've got your K times 3L up there. I'm just going to leave it. And I'm going to square all of this stuff. Square the top, square the bottom. 1 squared, 1, 2 squared, 4. Now, we're just kind of in a little fraction simplification problem. You can never, of course, or should never, I should say, have a fraction within a fraction. So I'm going to try to condense or clean this up or simplify 3/1/4. Well, if you divide by a fraction, you end up multiplying by the reciprocal. So I'm really thinking, okay, well, what's 3 times 1? 12. So I'm going to make that 12. And I don't know why I'm putting a dot. How about K times 12? So I've got the K. I'm going to make this 12 up here. And just D squared's on the bottom. So I just figured out the 3/1/4. That's all I've done. Now, final answer here. If the distance is cut in half, yeah, I did it. Luminosity is triple, yeah, I did it. By what factor will the brightness change? Well, clearly, you've got the 12 in here now from our original equation. We've got the 12 up there, so it's 12 times as much. That's for my final answer. 12 times is bright, since we're talking about brightness, I guess. And again, just to point out, this one was the 1/4, because the 4 is in the bottom. You have 1/4 down there. Here we just had the 12. Ellie, were you going to ask me something?
I was just curious, when you multiply both sides